An orbital ring is a concept for a space elevator that consists of a ring in low Earth orbit that rotates at above orbital speed, that has fixed tethers hanging down to the ground. The structure is intended to be used for very high-speed transportation and space launch. The original orbital ring concept is related to the space fountain and launch loop and was explored in detail by Paul Birch and published in 3 parts in the Journal of the British Interplanetary Society in 1982. History. In the 1870s, Nikola Tesla, while recovering from malaria, conceived a number of inventions including a ring around the equator. As recounted in his autobiography My Inventions, another one of my projects was to construct a ring around the equator which would, of course, float freely and could be arrested in its spinning motion by reactionary forces, thus enabling travel at a rate of about 1,000 miles an hour. Impracticable by rail. The reader will smile. The plan was difficult of execution, I will admit, but not nearly so bad as that of a well-known New York professor, who wanted to pump the air from the torrid to the temperate zones, entirely forgetful of the fact that the Lord had provided a gigantic machine for this very purpose. The issue was presented by Soviet engineer G. Polyakov in 1977. Arthur C. Clarke's novel The Fountains of Paradise is about space elevators, but an appendix mentions the idea of launching objects off the Earth using a structure based on mass drivers. The idea apparently did not work, but this inspired further research. Paul Birch published a series of articles in the Journal of the British Interplanetary Society in 1982. Anatoly Yunitsky also published a similar idea in 1982. Birch's model. In the simplest design of an orbital ring system, a rotating cable or possibly an inflatable space structure is placed in a low Earth orbit above the equator, rotating at faster than orbital speed. Not in orbit, but riding on this ring, supported electromagnetically on superconducting magnets, are ring stations that stay in one place above some designated point on Earth. Hanging down from these ring stations are short space elevators made from cables with high tensile strength to mass ratio materials. Although this simple model would work best above the equator, Paul Birch found that since the ring station can be used to accelerate the orbital ring eastwards as well as hold the tether, it is therefore possible to deliberately cause the orbital ring to precess around the Earth instead of staying fixed in space while the Earth rotates beneath it. By precessing the ring once every 24 hours, the orbital ring will hover above any meridian selected on the surface of the Earth. The cables which dangle from the ring are now geostationary without having to reach geostationary altitude or without having to be placed into the equatorial plane. This means that using the orbital ring concept, one or many pairs of stations can be positioned above any points on Earth desired or can be moved everywhere on the globe. Thus, any point on Earth can be served by a space elevator. Also, a whole network of orbital rings can be built, which, by crossing over the poles, could cover the whole planet and be capable of taking over most of freight and passenger transport. By an array of elevators and several geostationary ring stations, asteroid or moon material can be received and gently put down where landfills are needed. The electric energy generated in the process would pay for the system expansion and ultimately could pave the way for a solar system-wide terraforming and astroengineering activity on a sound economical basis. If built by launching the necessary materials from Earth, the estimated cost for the system in 1980s money was around $31 trillion if launched using shuttle-derived hardware, whereas it could fall to $15 billion with bootstrapping. Assuming a large orbital manufacturing facility is available to provide the initial 18,000 tons of steel, aluminium, and slag at a low cost, and even lower with orbital rings around the Moon, the system's cost per kilogram to place payloads in orbit would be around 5 cents. Types of orbital rings. The simplest type would be a circular orbital ring in LEO. Two other types were also defined by Paul Birch. Eccentric orbital ring systems. These are rings that are in the form of a closed shape with varying altitude. Partial orbital ring systems. This is essentially a launch loop. In addition, he proposed the concept of supramundane worlds, such as suprajovian and suprastellar planets. These are artificial planets that would be supported by a grid of orbital rings that would be positioned above a planet, supergiant, or even a star. Orbital rings in fiction. Donald Kingsbury described a partial ring in his novel The Moon Goddess and the Sun. The manga Battle Angel Alita prominently features a slightly deteriorated orbital ring. The second iteration of the anime series Tekkaman features a complete ring, though abandoned and in disrepair due to war, and without surface tethers. In the movie Starship Troopers, an orbital ring is shown encircling the Moon. The anime series Kid Grade also uses orbital rings as a launch and docking bay for spaceships. These rings are connected to large towers extending from the planet's surface. The anime Mobile Suit Gundam 00 also prominently features an orbital ring, which consists primarily of linked solar panels. The ring is connected to Earth via 3 space elevators. This ring effectively provides near unlimited power to Earth. Later in the series, the ring also shows space stations mounted on its surface. Orbital rings are used extensively in the collaborative fiction world-building website Orion's Arm. Arthur C. Clarke's 3001. The Final Odyssey features an orbital ring held aloft by 4 enormous inhabitable towers at the equator. In the close of Arthur C. Clarke's Fountains of Paradise, a reference is made to an orbital ring that is attached in the distant future to the space elevator that is the basis of the novel. The game 10-3 Terran Conflict features a free-floating orbital ring around the Earth, which is shattered by an explosion and subsequently deorbited in X3.